Welcome to Brain Vision.
So we have a ball of mass m starting at height h, and first we're going to view this system as the ball and the Earth as one whole system. So that means if we want to do conservation of energy, well, the ball is going to have a change in kinetic energy, and it's also going to have a change in potential, and this is really gravitational potential, so I'll just write that in. And then there's no work or temperature or anything that we need to worry about, so this is going to sum to 0. So then we can put the kinetic energy on one side and the potential on the other side. This becomes minus. So the change in kinetic energy is going to be 1/2 mv squared, but the thing that's changing is the velocity. So I'll say vf squared minus the initial squared. So that's the change in kinetic energy. And then the change in potential, well, it's mg times the change in the y position. You can write h or y, but since we have h given, I'm going to substitute that in when we get there. So this is really minus mg times y final minus y initial. And now the mass cancels out, so it doesn't matter what mass we have. Our initial velocity is 0, so we're dropping it from rest, and we're looking for the final velocity. So this just becomes 1/2 vf squared. And then our initial position is h, and our final position is 0. So this is going to be minus g times minus h, because we have 0 minus h here. So now we get 1/2 times vf squared equals gh. So vf squared equals 2gh. And now since we're taking a square root, if this were velocity as a vector, we would need a minus sign in front because the ball is falling down, so the velocity would be pointing down. But since we're just worried about speed, it's just the absolute value, so it'll be positive. So this is what we get for the speed of the ball. Now, if we do the same thing but view it in terms of just the ball as a system, well, it still has a change in kinetic energy, but now it has no change in potential. Instead, there's work done by gravitational force. So the kinetic energy is still the same. This is 1/2 m times vf squared minus the initial squared. And the work done by gravity, well, it's going to be positive because the ball is moving in the direction of the force. And the force has a magnitude of mg, and it's moving a total distance of h, because that's the height of the ball. So you can see where we're going. This is going to end up being the same thing. Our initial velocity is 0, so this is 1/2 vf squared equals gh. And vf squared equals 2gh, and again we'll just take the absolute value so we don't have to worry about plus or minus. So the speed of the ball is again 2gh. So it doesn't matter which method we use, we get the same answer.